Yeah, hello. Good morning, everyone. Yeah, hello. The today topic is all about how we can detect whether it's a fraud news or not a fraud news. Okay, so before that, I like to introduce myself. I am Kamlesh. I am from Pantech Learning. So today we are going to see about news aggregation and fraud news detection using deep learning. Okay, so this program is conducted by Vignan Institute of Technology and Science. Okay, and the Department of Electronic and Communication Engineering. The topic is all about news aggregation and fraud news detection using deep learning association with Pantech e-learning. Okay, so before we enter into this topic, I like to give thanks to the college, the principal and convener and coordinator. I will one by one I will tell you the chief patron and destination, that is CEO of the Vignan Institute of Technology, named Sri B. Sarvan, and then Dr. G. Durga Sugumar, principal of VGNT, and then convener and coordinator Dr. N. Dinesh Kumar, the destination Dean Academic HOD of ECE, that is HOD of Electronics and Communication Engineering, and then about college, this Vignan Institute of Technology is actually it's chairman of Dr. L. Radhay, and then Vignan Group of Institute was founded in 1999, and then they have different type of branches, both BTech and MTech. So in BTech we have ECE, CSE, EEE, MEC, Civil, E&I, and then IT, DS, ML, and with AI. So like this departments are available with full educated accomplished faculty, and then world class facilities with hostel, over 350 acres of hostels itself. And then the department, this program is conducted by Electronics and Communication Engineering, and they have mostly intake of 16 and intake of, that is totally they have intake in 1999 16, and then 2014 the intake is 118, both in UG and PG. Okay, so they are well educated faculties in both Electronic and Communication Engineering department. So thanks for this wonderful webinar connecting by Vignan Institute of Technology and respected department ECE. And today's session is all about news aggregation and fraud news detection using deep learning. So let me enter into the session how we can find out the fake news in our data and how we can rectify it. Okay, so this is our today's topic. So let me start. Okay, so the first of all, this is the table of contents. We are using dataset analysis, and then we are using Google Colab. So I given as a Google Colab, but we are using Jupyter Notebook only. Why? Because the dataset is not uploaded till now. If I upload in Google Colab, means it takes some time. So that's why I am using a Jupyter Notebook, and then train and test splitting, and then accuracy score of confusion matrix and conclusion. Okay, so this is all about today's table of contents. Let me see about dataset analysis. Okay, so dataset which we have, this is our dataset. We have dataset of fake and real news. So opening, just wait a second. So this is data set. So the data set have different type of attributes like title, what title the news is based on, and then text, what is the news of that title. So here you can see this is the news, overall news. So each news have some this many lines. Okay, so this is the overall news, that is one cell. Within this one cell we have news, and then here we have a label, that is fake or real. Okay, so fake, real news. So this one is real news. Okay, so we have a news, we have a title, we have a news, and then we have a label whether it's a fake or real. So we know about this, about our data set. Okay, so which one is fake and which one is real, but algorithm wants to know, right? So after I am training the algorithm, if I give a test data, algorithm want to give the reply whether it's a fake news or whether it's a real news. Okay, so that's our main aim, right? So how we can do that one, let me see. So before that, here I am using a data set, fake or real news data set. If you need this data set, in description I given a link, data set link. You can click that link and you can download it if you need this data set. And I will enter into the Jupyter notebook. Okay, so here I am having a data set. So here you can see this is our data set, fake or real news.csv. So using this data set only I will train my algorithm and I will test my algorithm. Okay, so here I am created a new notebook file. So the notebook file is all about we can run our code line by line, that is each and every line we can run. So that is a notebook file. This is an interactive Python notebook file. So that's why here we are using. Before we entering into this code type, I need to give some details about data set and then how we can train. Okay, so normally if you take a machine learning algorithm, if you take a machine learning or deep learning algorithm, okay, so mostly the data should be in the form of like trained data, right? So we need to train the algorithm and we need to test the algorithm. But here we have a data set with only an text type, right? So here we data set we only have text type. So this text type the algorithm want to understand means it's difficult, right? So it's in a text format, but algorithm, most of them will know, algorithm will understand zeros or one like numerical value, right? So here we have only an text type. So how we can do this one, how we can convert this text type into the numerical type, that is feature extraction. How we can do means, for that purpose I am using here one of the feature extraction technique. The technique name is called TF-IDE. Okay, that is in from sklearn the default package is available about this function available, TF-IDE function. That is about this function I will use that one, use that data, and I will convert my data into an algorithm understandable. So for our understanding purpose I already have an data set example how we can convert our, see here. So this is the working of TF-IDF. The TF-IDF is nothing but the function which will convert our text data into the future vector form. Okay, so that is the use of TF-IDF. So here we have, for example, I am having a picture about document 1 and document 2. Okay, so in document 1 I have a word, this is a beautiful day. Okay, so in document 1 I have a word, this is a beautiful day. In document 2 I have a sentence, this is a beautiful night. Okay, so I have a document 1 I have a word of this is a beautiful day, and the document 2 I have a word of this is a beautiful night. Okay, so before that we need to do some data pre-processing. Okay, before we enter into the TF-IDF we need to do some data pre-processing like tokenizing, so converting the sentence into a words or removing unnecessary punctuation, like we have question mark or exclamatory or multiplication symbol like that, right? So we need to remove unnecessary punctuations, and removing stop words also. Stop word is nothing but like there, is, are, as, etc. Okay, like that we need to remove some unwanted words. Okay, that also important. And then stemming. Okay, so stemming is nothing but reduce the root. Okay, so that is, if you have a word of running means we can cut the word run. Okay, like that we need to do some process. Okay, about this process, last week only we done with the NLP. Okay, natural language processing. So within that NLP webinar, live webinar, I will do all this process like tokenizing, removing unnecessary words, and removing stop words, and removing stemming, how we can do lemmatization. So this and all I done already in one live webinar session last week. So if you are new to this channel, you please do watch after this webinar. That will be useful. Okay, because if you take normal text type of words, if you want to train the text type of words to your algorithm, definitely we need to do those basic steps, that is data pre-processing steps. Okay, so about data pre-processing we already done, so just to go and check it out after this webinar, and just to search it for others, just to go to the video session in our channel, and then just to scroll down, the topic is natural language processing. Okay, so to check it out. And so here I have a data set only with names with we have. Okay, like that we have only a text, right? So for that we can use natural language toolkit. Otherwise, if we have an data of HTML file or XML file, you can use Beautiful Soap. Okay, so Beautiful Soap is another library package, we can do that one. So this is the basic data pre-processing steps. Okay, we need to do, but we come into the future extraction step. That is important, right? So future extraction is nothing but normally they called as a like back of words. Okay, so back of words is nothing but it will be count the number of times of each word. Okay, and then it will be converted into an numerical values. Okay, so it will be count the each words. Okay, so here you can see, here it will be count the each words, how many times it's repeating, then it will be converted into an count value. Okay, so that is the use of this one. Okay, so how we can convert. Okay, so here you can, this will be repeated for one time. In document 1, this will be repeated for one time, is will be repeated for one time, a will be repeated for one time, and beautiful 2 times it's repeating, and a 5 times it's repeating. Okay, in document 2 we have like this. Okay, so night will be repeated for only 2 times, and other things and all only 1 time. So this is back of words. Okay, so back of words is nothing but it will be convert our words into the numerical form. Okay, so after you done this, you need to move on to next step. The next step is all about term frequency inverse document frequency. That is term frequency inverse document frequency. Okay, so term frequency inverse document. So we have document frequency, we need to convert it into the term frequency. Okay, so if you want to convert those, things, you need to do some process like term frequency and inverse frequency. So here you can see, first we will take an first document. Okay, in document 1 we have a beautiful repeated for 2 times, right? So we will take only a beautiful word. Okay, in document 1 we will take only a beautiful word. So how many times it's repeated? 2 times, right? So 2 divided by 10, then we will get an result. So idea beautiful is equal to log of 2 comma 2. Okay, then I will be get a 0. Then in document 1 I am taking again day. So day totally repeated for 5 times, 5 divided by 10. So 10 how means 5 plus 2 plus 1 plus 1 plus 1. So we will get a 10. so I am getting an output 0.30. So this is the important for me. Okay, so this data is important. Why I am doing why I am telling us important means this is the weight of my data set. So for document 1 we are having a weight 0.30 and 0. Okay, so based upon this weight only algorithm will be trained. Okay, so algorithm will be trained by using this weight only. Okay, so like that I am using for document 1 beautiful 0 and document 1 day 0.45. Okay, so after I am finding an TF, I am using for TF IDF. So TF IDF is like same thing only. Here also I am working, that is into 0 and into 0.30. That is what I am getting a result, it will be multiply with the dose result, then I will be getting another one final result. So these are the important data of my important weight of my data. Okay, so this is the things working of TF IDF. We also using this TF IDF and doing some process. Okay, so I hope everybody will get some idea about TF IDF, and then we will enter into the session about technical wise, and then we will check it out how it's working. Okay, so this is our data set. So the data set have both fake and text and label. Okay, so text is all about this one. Okay, so now what we have to do means I will use my Jupyter notebook. I will import some package, import pandas as pd, import numpy as np, and import matplotlib dot pyplot as plt, and then import cban as sns, and then import. Here I am importing warnings also. So warnings means if sometimes the codes will be deprecated. Okay, so because Python is a version based, we have different type of versions in Python. So sometimes our current version and our newest version will be deprecated. So I am using warnings to filter those warnings. After I am running the cells, if I getting the warnings, I will ignore that warnings. Okay, so I am running this cell. See here I am getting warnings, right? So this is called a warnings. Okay, so what I am doing means if I run it again, so warnings will be imported, then it won't show. Okay, so that is the use of warnings. And now I imported some basic packages. Now I have a data set, right? So I want to read the data set. So here I am creating a new variable data. In the data I am using pd.read_csv to read our data set. So read_csv, and then what is the data set starting, fake or real, right? So if I give only a f fake, then I will use tab button, means automatically it will be give suggest which one I need to import. So okay, so fake or real, news data set. So I am running this cell. So now it's run data.head. I am running the output. Okay, so here you can see we have a data set with unnamed and then title, text, and then label. Okay, so this is the output. Okay, so text and then label. So this is the output, so title and label. Okay, so now what we have to do means, now everything is reader. Okay, so our data set is reader. Now what we have to do, I will tell you. Okay, so create a new cell here. Now we can check the data dot shape. Okay, shape is the keyword to find how many rows and columns in our data. So totally I have a 6335, that is 6335 data newses we have. Okay, so we have up to like this 6335. Okay, so this is our shape, that is some rows and columns. And then next one, what we have to do means, we will check some other. Okay, so head we done, and then even we done with shape also, and we can use some other plotting, and we will check how many labels are available in our dataset. So we know fake means fake news and real means real news. Okay, so we will check that one. So using SNS dot count plot. So Cban have some count plot function. Using this function we can plot labels. Okay, data, in data we need to plot labels. Okay, so here I am running the cell, key error. So what is the label spelling? You can check it out. LABEL, LABEL. Okay, so running. Here you can see, so totally we have fake and real news data, and fake is this much and real. So totally we have 6000, right? 6335. In that 6335 we have 3000, more than approximately 3000 fake news and 3000 real news. Okay, so my data set in balanced manner. Okay, balanced manner means there is it's now we can use this data set, we can train the algorithm. Why? Because sometimes the data set will be imbalanced manner. So at the time you will be, if your data set is in imbalanced manner, you will be do like underfitting, overfitting, and all will happen. But here my data set is now balanced manner only, so it will be give only optimal fitting maximum. Okay, so that is what we are using this count plot and to check whether it's a under imbalanced data set or a balanced data set. Okay, so now everything is done. The next one we need to go for train and test splitting. Okay, so we need to split our data set into two types, train and test splitting. From sklearn dot model selection import train and test splitting. Okay, train and test splitting. So I imported. Now I will divide my data set into two types, X train, X test, Y train, Y test. Okay, so before that I will tell you one thing about what is the use of X train and X test. Okay, so normally what we have to do means, if I use paint, so basically what is machine learning definition? So machine learning or deep learning, so we need to give some data. Based upon the data, algorithm will be trained, and then after that if I give a new input, for this new input I will be get an output, whether it's a fake or real. So this is the basic idea of machine learning or deep learning. Okay, so here I want to give the data set with, actually here today our data set is a supervised learning. Okay, supervised learning means we have a data with output, that is we have a data means we have a news and we have an output also. The output is nothing but according to that news whether it's a fake or real. We have both data and output, right? So I am giving this train and I will give the both data and output to train the algorithm. After I am training the algorithm, I will give only a new, that is new data only, not any outputs. Okay, so for this new data only algorithm will be give the result whether it's a fake news or real news. Okay, so data and output I want to give. So for that purpose I am creating an X train. So here X represent data and then Y represent label, that is output. Okay, so output. So this is the basic things we want to here represent. So X train means the data which I want to train, and then Y train means the data have trained data na, so that the trained data output will be saved in Y train. Same thing, X test means the data which I have to test, the test data output, original output will be saved in Y test. So that is what here we are doing. Now I am calling a train and test bit function, already we imported. Within this train and test bit function I am directly taking a data in data, that is, this is my variable name. In this variable name I am saving my data set, right? So in data I am taking a text, that is newses. Okay, newses in one, newses I am passing newses name text, right? So here I am passing a text, and then after this again I am calling a data. I am passing only an output label, label. Okay, okay, so that is what here I may explain. Okay, so we have a data and we have a label, that is this is dependent and this is independent, that is based upon the newses only. This is the dependent label. Newses will be, we will be get an output whether it's a fake or real. Okay, so dependent one variable and independent one variable. Okay, so this is the way we can do. And then next one we have we need to give the test size, test underscore size. Okay, so test size 0.3, that is 30% of data. If you give 0.2 means 20% of data. Okay, so that is the use of this one, test size. Then I am running this cell. Now if you use print statement, if you check the shape of train, you will be get an output. Here you can see X train. Okay, shape of X train dot shape. Here you can see totally we have 4434. Okay, that is 70%. Here I am splitted test size equal to 0.3. 0.3 means 30% test size and 70% train size. So train size 70%. So if we check in new line, if I create in new line. Okay, so here I am passing the item. In new line I am passing the data of same shape of the shape of test. So if I pass shape of test, so here also X test dot shape. Here you can see I am getting a 30% of data. So 70% of data will be saved in train data and then both 70% of data, train data we have now, the data of the output will be saved in Y train, and then 20% of data will be saved in X test, the X test data will be saved in Y test. So this is the uses of train and test splitting. Okay, so now everything is done. If you use X train and if you print the column, means we have everything, every newses. Okay, so newses will be there, and if I use X train instead of X train, here Y train means we have an output whether it's a fake or real in here. Okay, so this is the thing we are doing here. Now what is the uses means, next one, now we have to do for TF-ID. Okay, so that is important. We need to do some feature extraction in our data. So till now we are not converting our text data. So now we are importing some future sklearn dot feature extraction dot text. Okay, so from sklearn feature extraction dot text, and then import TF-ID. Okay, so now we are importing a TF-ID vectorizer. After importing a TF-ID vectorizer, I am saving my TF-ID vectorizer in one variable, that is TF-ID. So here I am calling a TF-ID vectorizer. Then I am removing the stopwatch. So stopwatch we already discussed about stopwatch. So I am removing the stopwatch, that is there, or that and all English, and then here I am. So next one, I am using TF-ID vectorizer, and then I am converting my function into the new variable. Then next what I will do means I will convert all my train data. For example, you can see train data X train. So here we have only a text. Okay, so we need to convert those text into the machine readable. So for that purpose I am using this TF-ID, and I will convert each and every data. Okay, so that is the use of next one. So here what I want to do means I will transform underscore X train, that is train data, and then transform underscore X test, that is test data. Okay, so here I need to transform, but I need to pass my data, right? So I am calling the TF-ID. Into TF-ID I am using fit transform. So fit transform, using fit transform I am transforming my train data, X train data, and then same thing TF-ID dot fit transform X test data. So I am transforming my train data and test data. So here we have now that one. So here I am running this cell. So it's run. So if I use this, if I display print the output, we will be like this only. Okay, it's in a compressed RAM, compressed sparse row format. Okay, so like same thing only for transform X test also. Okay, now we can import an algorithm and train the algorithm. Okay, so for example, I am importing an algorithm from sklearn. Okay, from sklearn I am importing an algorithm, that is any linear model. Okay, linear model, import passive aggressive classifier, because it's a supervised learning, so classification type, so we are using passive aggressive classifier. Then I am creating a new variable passive equal to then passive aggressive classifier, then I am passing the iteration maximum iteration, how much data we need to give. So I am giving 100, then I am running this cell. The next I need to train the algorithm. Okay, so now we converted our data, that is our train data and test data, into an algorithm readable. So now what I am doing means I am giving the train data and my train data output, that is stored in y train, right? So I am giving this x train data, that is transformed x train data, and y train I am given to the algorithm to train the algorithm. Okay, so passive, if you want to train the algorithm in machine learning or deep learning, you need to use fit function. So using fit function, I am giving the train data and then train data output. Okay, so I am running this cell. Here it's trained, so I am not getting any error. Now after this you need to check the output. Okay, so now the algorithm is trained. Now in the algorithm we need to give the new test data. The algorithm wants to predict the output whether it's a fake or real. So passive dot predict. So to test the algorithm in machine learning or deep learning, predict is the function to test the algorithm. Here I am passing the x transformed test data, right? So transformed x test data, but we need to, after predict the result, passive aggressive algorithm will be give the output whether it's a fake or real, like that. Okay, so I need to save that output data into one new variable. So I am give output, and then I am running. Okay, so I am running this cell. It's value error, transform x test predict passive. Okay, so here passive dot predict and transformed x test data, I am getting value error. What is that value error? Okay, x has a future only this many, and we need expecting this one. Okay, here we transform x train, okay, one y train, and then transform x test. So this one we need to use here, transform x test. But what happened if I display x test? Means what is the output? Okay, everything is fine here, and then why it's not showing, why it's not training? Value error passive dot out fit is trained properly, transform x test. Just wait a minute, I am running the cell again, and then again it's getting an x has a 40902 future per sample, accepting this one. Okay, so next what we have to do means I will run the whole entire cell. If I am getting again same error, means I will show my backup code to you. Okay, how I have backup code, I will show you that backup code. Value error only. So something I made a mistake, I think, but everything is future sample only expecting. Okay, wait a minute. Transform x test. Okay, dot save. Here you can see we have totally two type, right? So transform x test but if you are printing for white X train, you will be have only like this. Okay, so the way of splitting, the way of training is different, I think. Okay, so it's not a problem. We have a code. Here you can, up to this we done, right? So after I am passing this one, I will run the cell. After I am passing this one, I will passive aggressive classifier will be predict an output. Those output will be saved in this passive output underscore output data, and then I will use the confusion matrix. Okay, so accuracy score and confusion matrix. So accuracy score and confusion matrix is nothing but it will be give the result of how much algorithm will be predicted. So 93% algorithm predicted. Okay, but it's a percentage wise only. You can use confusion matrix and you can calculate the this one. Okay, so confusion matrix is all about like can create a new. Here if you are using a 2 type of classification, we will get a 2 into 2 confusion matrix for fake and real. So first one is all about wait a minute. So here 879 and 902. So which one will be take it as a fake? So first one will be fake, next one will be real. So here fake newses and then real newses. Okay, so here I am getting 879. So 879 in my test data, 879 newses will be a fake news, and in my same test data totally 902 newses will be a real news. Okay, so these two is represent this 93%, that is 93% algorithm predicted correctly. Okay, then we have 56 and 64, right? 56 here and 64. Okay, what its represent means, normally they will call as a true positive and then true negative. Okay, here they will call as a false positive and then false negative. The false positive and false negative is nothing but here I am getting 56, that is false positive means suppose it's to be a fake news but machine predicted as a real. Okay, that is 56. It is fake news only, 56 news, some other 56 news will be a fake news only, but it's predicted as a real news, that is false positive. False negative is suppose it's to be a real news but algorithm predicted as a fake news, so that is 64. Okay, so that is the representation of confusion matrix. So we done with the fake news, how we can do. Okay, so everything we performed as it is same this code only, but I got a error. So error is about shape only, shape, the shape of training and testing is different, so we need to check about this. So this is the code. Okay, so this is the output if I get in this also. Okay, so I hope everybody will get an idea about how we can train the machine learning text based algorithm. I think this is the first time we are doing with text based data set in this Pantech e-learning channel. So everybody will understood about this. If you have any doubt you may ask, otherwise okay, so this is the thing we are going to see. So thank you for this wonderful webinar. If you have any doubt you can ask in our comment box. Otherwise, we will finish it off this session. Okay, so I would like to tell about something about internships also. We are conducting an internship. So internship is all about like IETE Technical Training Program internship. So it started 3rd August and 5 days training program, each day 2 hours. So if you need to join with this internship, you can join. For ISF members 300, for non-ISF members 350. Okay. And we are starting 15 days internships also, like different type of domains like deep learning, machine learning, and electric vehicle and app development, IoTs and all. So if you are need to know, you can just check it out. And then so this is 15 days 1600. Okay, so if we have another like week 5 only available, week 4 this week only, and week 5 are available, that is 29 to 13th. So practical approach of Microsoft Azure and protocol, and practical approach of computer visions. So if you need to join for 2 days online workshop series, means you can join with us each day 2 hours. Okay, and if you want to register for those workshops and webinars, you can contact those Mr. Sendil Kumar, Mr. Srinivasan and Mr. Kumarasamy. They will help you regarding that. And then thank you for this wonderful webinar by Vignan Institute of Technology. And then if you know upcoming events, you may join with WhatsApp and Telegram also. Okay, so thank you all.